Has anyone already done that? There is a chance that it's non-calculator. Sometimes they will make you do that non-calculator. 40 divided by 220 times 3 is 60. Plus 7 is 160. So there you go. Answer the following, and this should help with some of the difficult questions on your homework. If the integral from a to b of f of x dx is greater than 0, then f of x is positive for all x in a b. True or false?
True.
Do what? You do what? Why? I don't know anything about x, right? I just know that overall the area comes out to be a positive value. So, false. There, you could say something about the integral from a to b is positive, but f of x could be negative at some point from a to b. If f of x is positive for all x at a b, then the integral is positive. That is true. Why? Right, if everything's positive, the area has to be positive. Right? Now just because the area is positive doesn't mean the whole function was. But if the whole function is, the area would have to be positive. If the integral from 2 to 5 of f of x is 18, then what is the integral from 2 to 5 of f of x plus 4? What can I do to that integral? Right? Okay, the left is easy. The right, I've got to think a little.
Equals 4.
Doesn't equal 4. What is it? What is the... Yeah. Okay, so all I did so far was break it up. Yeah, but like how do you get the second part? Good question. What is the only way I know how to do integrals as far as today goes? Area, right? The only thing I know how to do is draw pictures into the area. In about 10 minutes, we'll know more than that. Okay, 4 times 4, right? From 2 to 5. So with 3 by 4 is 12. So that's a tough problem. I couldn't just do that by looking at it. So 12 plus 18. So that's tough. That might help you on a homework problem. You see why I'm letting you keep the homework. Any questions about that? We didn't do one like that yesterday. So I needed a picture to do the integral from 2 to 4. And actually, you won't know how to do that quite today, but we're getting there today. Getting close. Any questions about that? So we're going to look at that picture really quick. Probably going to have to go over this. Made you a pretty picture. Okay, and I just want to explore something really quick. Okay, so I have a function here, f of t. And I have an x value that's value I can move around. So this thing, I can move it around, okay? So I have like f of 1.8, all of those things. Okay? I could find the area underneath that if I wanted to. And so I've got that. As I slide X around, it'll change the area appropriately. Okay. So I'm going to name a new graph G of X. And that's the accumulation of this area. So as this area changes, oops, as this area changes, see how the curve changes? So this is plotting the area. Does that make sense? Any questions so far? So this is plotting the y value being the area of that. This is the derivative of that area graph. What is it? The same as. What is that derivative? The same as. The y value on the original. So the derivative of the integral is the original. It's weird, isn't it? Say that one more time. This is one of those moments. The derivative of the integral gives you back the original function. What does that mean? If I do the integral and then do the derivative, it takes me back to where I was. What does that mean about those two operations? They're inverses. Oh my goodness. Whoa, right? That's crazy. The area underneath the curve and the slope of a curve are inverses. You see why it took Isaac Newton and Leibniz so long to figure that out? That's crazy. So, this is called the fundamental theorem of calculus. It is like the calculus theorem. Yeah.
I guess they are.
It's important. It's a big day. Like, your cell phone works because of this day. It's crazy. Like, this opened up physics and technology. Like, this is a big day. Huge.
That means there's a constant Christmas. They will always say, more.
So, the fundamental theorem of calculus, in plain English, is that the derivative and integral are inverse operations. That's what it says. I'll walk you through the wording, but it says that the derivative and the integral are inverse operations. And you saw that numerically as I was just calculating some things. It just happened. So let f of t be continuous on a closed interval. It has to be continuous so that we can find area underneath it, right? We'd have a hard time finding the area underneath a curve if it had an asymptote in the middle. So, talking about a continuous function. If g of x is the integral, the area from some constant a, so from some value a, to the variable x. So we're going, say you're going from 0 to x. That x being the variable. Then the derivative of the integral is f of x. So Joseph said it. That technically means that an integral is an antiderivative. That's a new word. It is not. It's amazing. Okay, now put yourself in someone's shoes. Do without a calculator, because if you didn't know, Isaac Newton did not have a calculator.
Oh, wow.
I'm pretty sure. Now he had one up here, but not in this case. So imagine having just finished finding lots of areas without like lots and lots of areas, lots and lots of rectangles. Okay, we did it with a calculator, it wasn't too terrible, but imagine without a calculator. Wouldn't you want a faster way to do that? This is an exciting day. Okay, so we will get there. Not quite today, but maybe the next one. So it's amazing that the derivative and integral are inverses. It is hard to visualize graphically, and that's why I pulled that animated thing in. It was very helpful. But g of x is the function that accumulates area and under the graph of f of t. It is the antiderivative of f. That's what we'll be looking at today. So, if derivatives and intervals are inverses, then we could undo, right? So we're going to undo. So I'm going to start with the first one. The derivative of constant is 0. So the integral of 0 would then be a constant. Okay, why is that? If we're talking antiderivatives. If the derivative is 0, what could the function have been? Any number, right? Could have been any number. A constant. Just a quick guess of the next one. Any ideas? What could the next one be? Power rule. Okay, so say we have x squared. What's the antiderivative of x squared? Okay, 1/3 x cubed. Why? Good. Right, multiply the 3 down and reduce the power by 1. Oh, that's the next one. Okay. I'm getting it. The antiderivative of 1 would be x. Would you agree? Or even in general, the antiderivative of any constant would be that constant times x. Why is there a... Let me move that hand out of the way. Why is there a plus c? Because it's 0. There could have been any number there, right? Those would go away when I get the derivative. Here's the power rule. The derivative of the power is bring the power down front, subtract 1 times power. They do have chain rule here. We're going to ignore chain rule for today. We'll talk about it on a much later date. So I have an integral of u to the n du. To undo, wouldn't I need to raise the power by 1? To undo the subtracting 1? And then wouldn't I need to divide by the new power to undo the multiplication? So raise the new power to a higher degree. So if it's x squared, you'd make it x cubed, right? And then you divide by that new power. So divide by 3. That's where you got the 1/3 x cubed. Any questions about that? What'd you say? Okay, e to the u is easy because the derivative of e to the u is. So the integral of e to the u is e to the u plus c. Why plus c? Because e to the x plus 3 has the same derivative as e to the x. So we have to take into account the treatment of constant. The derivative of natural log of u is 1/u. Now you haven't talked about the absolute values before, but can you plug anything into a logarithm that is negative? words, we have to be careful about that, so that's why there's an absolute value on this logarithm. The integral of 1 over u is that's log of u with absolute values, because that u can't be negative if we're going to put it in a logarithm. What number are we on as far as writing it down goes? Ln. Is anyone higher than ln? Oh, higher. So move down to ln. Derivative of sine of u is cosine of u. So, the antiderivative of cosine of u is, I'm going backwards, sine of u. The antiderivative of sine is a little bit tricky. What function has a derivative that equals sine? Negative cosine. Why is that?
Because if you take cosine x negative sine, you have negative x positive.
Don't follow that. The derivative of cosine is negative sine. So the antiderivative of sine is negative cosine. I'm doing derivatives. The derivative of secant u is secant u tangent u. So the antiderivative of secant u tangent u is secant u plus. Do you know what your next gateway exam is? Do you have a calculus helper? If you need a new one, there's one behind you. Flip to the other side.
Oh!
Our next one will involve the antiderivative of tan inverse. And well, the derivative of tan inverse is u prime over 1 plus u squared, 1 over
it that way because we haven't figured out how to do it yet, or because it's not bad?
There is not one product rule or one quotient rule. There are some integrals that you can't do by hand. So someone has asked me last year, maybe even this year, I don't remember, would you ever really use this Riemann sum stuff? Yeah. If you don't know how to integrate it algebraically, then you're going to use a Riemann sum. So yes, sometimes you just can't. If you don't believe me, do not pick up a pencil at this moment. This is from the back of a college calculus textbook, and it is titled A Brief Table of Integrals. You ready for this brief table of integrals? Okay. Do you need to know all these? No. And what are they? They are specific derivative integral reversed, right? There are infinitely many integration rules because we can sit and look at every derivative and say, okay, let's go backwards. Here it is. So some of them are, now some of these are functions you don't know, but it's, pretty intense. We are not going to memorize this entire table.
How many are there?
We are going to memorize this entire table. So if we look back here, it might look like we've got 13 new things to memorize. Do we?
Yes.
Really have 13 new things to memorize?
We have 13 ways, like,
Right. I mean, really, you just undo what you already have memorized, right? You think about it. Here it is. So today, now, what we are not doing yet today is how to find an area using this. We will talk about that tomorrow. Today, we're just going to practice anti-differentiation. The first thing you want to do is simplify if it's helpful. You remember us doing that same thing on derivatives. First thing we would do is if we could divide things out, we would. If we could simplify it, we wanted to. We didn't want to do a product, we didn't have to. We didn't want to do quotient, we didn't have to. Well, now it's not if we don't have to, it's we can't. So we have to simplify. Now the first one requires no simplification, so skip simplified form. So let's talk about the antiderivative of x to the fifth minus 3x plus 4. We did learn yesterday that we could do that piece by piece, right? With pluses and minuses in between, we can break up integrals. So what's the antiderivative of x to the fifth? Well, what would the new power be? Does everyone agree? X to the sixth would be the derivative. What would be that? Well, how do we, if I multiply that 6 down, it's gone, right? How could it be gone? 1/6. Everyone agree? That is the antiderivative of x to the fifth. What about minus 3x? Good. The power's 1, right? So what am I going to do to that power? Add 1 to it, right? Because I'm undoing a derivative. So it's x squared, and I want it to be a 3 in front, not a 6. So to get that 2 to go away, I divide by that new power. The 3 is just a constant, so it kind of hangs out. Stay there. Questions about that? Does everybody follow how this is working?
Divide by
the new exponent. Find the new exponent, divide by. That is the power rule for integration. Plus what? 4x. Does everyone agree? What has a derivative of 4? Because the derivative of that is 4. Now, you have the rules, but at some level trouble, you can just think of going backwards. Y plus C, I heard someone say it. Why? There could be a constant there because when I take a derivative, all constants disappear. So I have to take into account that there could be a constant there and write plus C. Will you miss problems on the gateway exam if you forget the plus C?
Yes.
Yes. There is a certain type of calculus problem that you'll see next chapter. You get a point on an open response AP problem for writing plus C. Every time they ask that problem, they give you a point for writing plus C. We want that. That's an easy point.
So is the next chapter in BC?
No. We still have 3 chapters in AP. We may mix in a couple of BC things in those, probably not a lot though, and then BC. Now what? Good. Now, I'm going to write it as a simplified form. We don't have to do that. If you could just do what Joseph did, do it. But what I am going to do is the constant might make your brain have to think too hard. On polynomials, I think we're okay with constants, so we don't worry about them too much with polynomials. But with other strange things, they might hurt our brains. So what we can do, we learned yesterday, we can move the constant outside the limits of integration. That way I only have to think, what's derivative equals sine of x? So you tell me, what's derivative is sine of x? Negative cosine, right? Because the derivative of cosine is negative sine, so I need to throw in an extra negative there. So that's where I get the negative 5. Cosine of x. So this is antidifferentiation, which will lead us to very fast ways of finding areas under curves exactly. Pretty amazing. Okay, the next one, you agree the constant might be in our way a little? So I'm going to move it in front. This next one is one of the most commonly missed or forgotten rules, maybe. Although you won't forget it because my students don't forget it. It looks like you might make that x to the negative 1 into a power rule. Try to do x to the negative 1 as a power rule. If you did, what would be the problem? You get x to the 0 power, and that doesn't make sense, does it? But that's not right, because the derivative of x to the 0, x to the 0 is a constant. The derivative of that's 0. That's not right. So, how do you do 1 over x? Natural log. What has a derivative of 1 over x? Natural log, right? So, that answer is 4 natural log. This is new. You do have to put in an absolute value there. Let me remind you why. For this function here, this integration function, I haven't told you what x is, right? Could it be negative? Can that be negative? No, so we have to compensate for that and put in a positive value. Any questions about that? Okay, the next one, I'm going to play the same trick with that 4, except it's not really a 4, it's a 1/4. Whose derivative is cosecant squared? And what is the derivative of cosecant? Negative cosecant squared. So how do I fix that? Negative. Am I going too fast? Do what? Oh, okay. Okay, the next one. It would be very complex if I left it like it is, right? I don't even know how to do a quotient. You see a quotient, that's a problem. We've got to fix it. We don't have a quotient rule for antiderivatives. So what do we do? Divide. integration, you have to, but with derivatives, you want to. Negative 2x divided by x. And then the 5 over x, I'm actually going to leave that as 5 over x. Why am I going to leave that as 5 over x, not x to the negative 1? Good, when I have that x to the negative 1, it's natural log, it's special, right? Because I can't raise it to that number. And the antiderivative of 1 over x is natural log. What's the antiderivative of 5x? 5 over 2x squared. Now let me walk you through the thought process on that if you were stuck. Raise the power first, and then divide by the new power. What about just minus 2? What do you do with a constant?
Minus 2.
2x, because the derivative of 2x is 2. Plus 5 ln, don't forget absolute value of x, and then plus c. On your homework tonight, it would be very wise of you to do what? Well, true. Before that, yes. Check your answer. What do I mean by that?
If you don't get that when you simplify this, then you're wrong.
Do the derivative. If you don't get that, you're wrong. Right? You're really good at derivatives. Integrals are new to you. They hurt your head today. They won't hurt your head this bad always, but just take the derivative, see if it's right. It's like factoring. You can't get it wrong without not knowing you're wrong, right? Yeah. Better be. Or we messed up. Does that make sense? Okay. This one, we've done this before with derivatives, but it's been a while. What is the square root of x the same as? X to the 1 half power. Can you divide those two by subtracting the exponents? 2 minus a half is what?
1 plus 5.
And I am going to write that as 3 over 2. So it's just a power rule. It looks nasty, but it's just a power rule. And then I'm going to leave cosine of x. So the antiderivative of x to the 3 halves, I'm going to add 1 to the power. What's 3 halves plus 1?
5 halves.
5 halves. My first year teaching calculus, the kids I had never had their calculators taken away. That was the hardest thing for them. On integration, I couldn't add. What? It's a 3 halves. We all are much smarter. And then what? Divide by the new power. So I'm going to divide by 5 halves. What's that the same as doing? And check it. Does 5 halves times 2/5 go away? And you subtract 1 and I did good. Antiderivative of cosine? Sine. That one's a tough one. It's really hard to retrain your brain on that. The negatives go backwards, right? The antiderivative of sine is, or cosine is just sine. Antiderivative of cosine, or sine is negative cosine. What about the next one? There's not any simplification I can do, is there? Look, calculus helper. Any help anywhere? Heard it. Did I hear it? Did you find it? So is it not on there?
No, you gave it to us above.
Nope.
Yeah, it's number 17.
Okay, so you had to look at the derivative. We'll have to add that. Any questions about that one? I'm not going to actually do this next part, but you should. I'm not going going to because I'm good at integration. But you should because you're not good at integration. What do I mean by check our answers?